Good day, Free State learners, Matric 2014. I'm happy to be here with you, and then today we are going to do arithmetic sequences and series. My name is Zonisele Zweni from Comtech School. I hope you are going to enjoy the class that we are going to have today, as we are going to do the arithmetic sequences and series. And then we are going to start with the series, the sequences and series. Let us first consider what a sequence is. In simple English, we say the sequence is just an ordered list of numbers. It means there's a list of numbers that must be an order in it. So we say that is a sequence. If we start with, we are going to start with arithmetic sequence. We're going to start with arithmetic sequence. We just now said a sequence is nothing else but an ordered. We said it's an ordered list of numbers. This is what we said a sequence is. Now let's just consider the sequence that we are going to start with. Let's consider the sequence, for an example, 1, 3, 5, and 7. It can continue up to there. Let's consider that sequence. But we know that a sequence can be written in the form that T1, we can have T2, we can have T3, we can have up to Tn, where Tn is the nth term of that sequence, and then T1 is the first term, T2 is the second term. In our example here, we can say this is the first term, the second term, the third term, and then you can continue and so forth. Then now, this sequence, we look at it this way and say, what has happened to the first term in order for me to have the second term? What has happened to the first term for me to have the fifth term? Those things, that information is going to help us in ultimately we'll be able to find the general term. In other words, we'll be able to get the term after 7. We can get the term after the second term after 7 by using that. So this one we say this is T1. This is the first term. This will be the T2, the second term, T3, the third term, T4, the fourth term. Now, when we want to continue forward getting the other terms, it means we need to come up with a general term that is going to help us to find the terms of this particular sequence. Now, to start with that, this one T1 is denoted by the letter A. We denote this by the letter A. We say this is term number 1, or the first term of the sequence is denoted by the letter A. But now, since we have just talked about the order, there must be a certain order in this sequence. Where does the order come from? We look at now what is the difference between these terms. How do they differ? We realize that now the difference, when we get the difference, we find it as D, which is the difference, and the difference is given by the second term minus the first term, which can also be equal to the third term T3 minus T2. In other words, you subtract the term from the previous term from the next one. So T2 minus T1, T3 minus T2. That is going to give us the difference in that. Now, because here, if you look at this one, you'll find that the difference between 3 and 1 is 2. The difference between 3 and 5 is also 2. Between 7 and 5, the difference is still 2. Then we say, now that this difference is common, or this difference is the same between the consecutive numbers of a sequence, we end up saying this particular sequence is now arithmetic. because of the common difference, meaning that what makes the sequence to be arithmetic, it's because it has a common difference. In this case, the common difference is 2. So we can continue now and find out how do we get the terms that will follow. It will be simple. Each and every time you add this difference, if we say 1 plus 2, you get a 3. That is the second term. The second term plus 2, which is the difference, you get the third term. The third term plus the difference, you get the fourth term. In other words, you can continue with this sequence by just adding the difference. Meaning that what we can also do will be, we know that our term number 1 is nothing else but 1. So to get term number 2, what has happened to that one? It means we have just talked about the difference there. We have said 1, to that 1 we add the difference. And then to get the term 3, term 3 will be 1, which is our first term. In that 1 we add the difference and then another difference. So it means now we are going to get a 5. If we can put them here maybe so that they are not far from us. Say this one is 1 as the first term. It is 1 as the first term. That one will be 3. That one will be 5. And then the next one is 7 there. So we say, in this case, this is our T3, which is going to be 1, the first term, plus the difference and another difference. Term number 4 will be the first term plus so many differences. 2, 2, and 2. Ultimately, we realize that 2 plus 2 plus 2 is 6, plus 1, it gives us 7, which is part of the fourth term of our sequence. It is now 7. So we cannot continue. Let's say, for example, if we are looking for term number 50, we cannot continue this way otherwise we'll run out of time. What we need to do now, we need to look at what is going to happen now, as in we go down like that. Say, for an example, we have T in term number, and then the term which is equal to 9. What are we going to do with that one? It is now, which term is that one now? It's 7, and then if it is 9, it means it's the one next to that one. So it means it will be term number 5. It is 1, and then to that one we add how many differences now? We add this difference, that difference, that difference, that difference. It means we have 4 differences in term number 9. Now let's see. If we take this further and look at what has happened in terms of D, we say 1 plus that one, 1 plus 2, which is a difference, 1 plus 2 and 2, which are 2 differences, 1 plus 2 plus 2 plus 2 plus 2, those are the 3 differences. In other words, this we can continue up until we get any term that we will be looking for here. Anytime we can be able to get that. But now this is specifically about the sequence that we have. But now it means we can say that one represented by A adding the difference. If we write this in terms of what we said, the first term was represented by A, and that is nothing else but the common difference. In this one, it will be A plus the difference and the difference. The same thing is, we continue with that one and say that will be the first term A added to the difference, and another difference. So we have A plus the 3 differences. That one will be the first one plus the difference, the third difference, and another D there. In other words, we can say now term number 5, the fifth term, is given by the first term with 4 differences. we can combine this at once and for all and say the term number 5 is nothing else but a plus 4 differences. So the same thing there. We can write that one as a plus 3 differences. The same thing will happen, that one a plus 2 differences, a plus 1 difference. This one, it is the same as 1 plus 0 difference. There is no difference there because that is the first term. Right. Now let's write it well so that we realize the pattern that we are talking about. We just said T1. We just said T1 is equal to 1. Then which can be represented by A. T1 is equal to 1. That is equal to A. That is T1. T2, which is term number 2, will be 1 plus 2, which can be represented by A plus 1 difference. Remember we said here 2 is the difference, 1 is the first term. So in that case we are going to have A plus the difference. The third term, it will be, if we take it to that now, it will be the first term plus the 2 differences which we had there. This plus 2 differences there. And then the term number 4 will be nothing else but A plus the 3 differences. Let's take term 5 for an example. Term number 5, if we take it this side, it will be A plus 4 differences. Now let's read the pattern. What is the pattern here? The pattern is the term number and the coefficient of the difference. We need to look at that. The term number and the coefficient of the difference. Term number, coefficient of the difference. Term number, coefficient of the difference. Now we realize that this can be simply written as, we can equate it to A added to the term number, which is 5. But from the term number we take out 1. So to have a 4. And then we multiply that by the difference. This one still, we can have the first term added to the term number, which is 4, take out 1 from 4, then we multiply by the difference. That one also will be the first term added to the term number, which is 3, take out 1 from the term number, we get the difference. The same thing there, it will be A, which is the first term, added to the term number minus 1, multiplied by the difference. Even that one, for interest sake, it can also happen that I have to see. This can be the term number, A, the first term, then the term number, it's 1 minus 1, and then you multiply by the difference. So 1 minus 1 will give us a 0. You multiply by 0, there you get that one. So now that we have realized what is happening in this pattern, we are able to see what is going to happen now if we are looking for, say, term number 10. I know you know that one. I know you know it very well. If you take that one, it is going to give us, in this case, it will be the first term added to 9 differences. The 9 differences come on our side, the green side there. We said it will be A added to the term number minus 1. You multiply by the difference. This is how it's going to be. In other words, every number that we have there as a term number, when we get to that, we subtract 1 from that. So to generalize it, to make it general, because we are looking for the nth term or the general term, it means if we say Tn will be nothing else but, here it will be the first term, you add, what happens to n now? N, we must lose 1. N minus 1, then we multiply it by the difference. So now, beautiful learners, this one now becomes the general term of an arithmetic sequence. It's a general term. How does it help us? It helps us, for an example, if we want to get another term there. You get another term there. You get another term. The terms that are following 7, then we can be able to get them using this one. To set an example, say, for an example, we are looking for term number 7 of this one. We are looking for term number 7, T7 of that. So T7 of that one, remember our sequence was, this is now as an example. As an example there, we know that we had 1, we had 3, we had 5, we had 7. Now this is T1, T2, T3, T4, there must be T5 there must be T6, there must be T7. Now we are looking for T7. We are not looking for other, we are looking for term number, we are looking for term number 7 there. So it means our formula, there's our formula, or our general term is there. Now the position is now the 7th position of that. So it means to our formula there, we are going to take it as Tn given by A plus into n minus 1 multiplied by the common difference D. Substitution. What is the value of A? A is there, which is term number 1. That is our A. This is the value of A. And then we know what is the difference there. The difference was 2. So we substitute now for Tn. And then the value for A is 1, which is our first term there. And then we add the term number. We don't know, we are looking for that. That is n, then minus 1. We know what is the difference. When we get here, we know what is the difference. Our difference is now equal to 2. From here, our algebra should work. So say this is 1 added to, we first work on this one. Most learners do not do that. They add this bracket into that one. That is a common mistake. So we first work on this side, multiply first. So it means we end up with we are looking for T7. Oh, now we have done something wrong here. Remember, we are looking for term number 7. Let's put it right here. We are looking for term number 7 there. So it means from the formula, Tn given by A plus into n minus 1 multiplied by D. You see, that is the mistake that I've also done here. I always suggest that before you can continue, just have your little data at the side there and write down A is equal to 1, D is equal to 2, and then N is equal to 7. I'm looking for Tn, which is T7 this time. So this is going to help us to be able to repeat the mistake that I've done here. Then it means when we substitute into that one, we are going to have, now we are looking for T7. We substitute right there. T7 is nothing else but 1, which is A, added to 7 minus 1. Multiply that by the common difference, which is 2. That is the common difference. So we work out there. This is going to give us a 6. That is going to be multiplied. It gives us a 12. It means we have a 1 plus a 12. Then the 1 plus a 12 is a 13. In other words, it means to us the term number 7 here will be nothing else but 13. That's how we have got that. So I always say this, for every formula, this formula contains variables like those. So you must be prepared to find any of those variables using the formula. You must be able to do that. So to continue from the general term is there. If anyone maybe has a question, matriculants, you can forward it to us. We can look at that. But up to so far, I think we are together in finding the general term. Here is the general term. We have found it, the formula, and then we apply this formula to find T7, which is the 7th term of the sequence that was given to us. So we can have this one, finding the general term. To find the general term of a specific sequence, because this one is the one that finds the other term. So what do we do in order to find the general term of a sequence, a specific sequence? A general term of a sequence. To find the general term, like this one, the one that we had here, it was 1, 3, 5, and 7. So what is the general term for this particular sequence? We can be able to find that because we know the general term for the arithmetic sequence. But before we can do that, we must first establish what type of a sequence is this one. Like we have just done, we have said this one, it gives us the difference of 2. So it is arithmetic. So for the arithmetic, it means we are using Tn equals to a plus n minus 1 multiplied by the common difference d. So what is the general term for this? We know here that our first term is 1 added to n minus 1 multiplied by the common difference. So it means as we continue, this is going to be 1 plus nd. nd from this, you multiply this by that one, we get nd. And then ultimately you get a d there. This is nd, that one will be a d. But we know that this d is equal to 2. So what do we have from there? It means from this step we'll have what? 1 plus into n minus 1 multiplied by 2. So we have multiplied that, as I've shown there. We have multiplied this way, so it means this should also be 1 plus 2n minus 2. We don't forget to multiply this, because most learners make the common mistake of, say, multiplying this 2 with n and then forget the other term inside the bracket to multiply with. Don't make that mistake. That is why I started to show you that this one should multiply there, and then ultimately this one must also multiply there. Both of them that are inside the bracket must multiply the common difference. So hence we have that one. But we know this and that one are common. So we can bring it here and say, all right, it means we are going to have now what? 2n, and then these two are common. 1 negative 2 or 1 minus 2 is nothing else but minus 1. What is this minus 2n minus 1? Tn minus 1, my good learners, it's nothing else but the general term of a specific sequence, not any. Remember, this is the general term for this specific one. The one that we had is the general term for any arithmetic sequence. The one we had here as Tn is equal to n minus 1d. That one is a general for any arithmetic sequence. But this one is the general term for this specific one. Remember, each and every sequence has its order, has the way that it is developed. So this one has this one. But you can also use the same general term of a specific sequence to find now the T7 we talked about at the bottom there. At the top here, we talked about T7. So we can use this specific one to say T7 is nothing else but 2 multiplied by 7, then minus 1. Ultimately, you get the 14 minus 1, which is 13. This 13, it is the 7th term of this arithmetic sequence. I'm sure up to so far we are going together. So now, to find the general term, it means we must first know the difference must be known, as we know the first term when the sequence is given. So let us make an example once more and take a question there that is going to, where we are going to look for the general term. We are going to do it together here. Let's look at this question here. Determine the general term of the following. That should be it. Determine the general term of the following. This should go as determine the general term of the following arithmetic sequence. So the sequence is given as 4, 7, 10, 13, and then it continues to infinity. So now to find the general term of this, we said the first thing that we need to know, to look at our A there is equal to 4. I'll write a little bit bigger. A is equal to 4, which is the first term. And then we look at the difference. What is the difference between the terms? The difference between the terms. It is now 7 minus 4, 10 minus 7, 13 minus 10. We realize that now our difference there is going to be nothing else but 3. That is the difference. So we are looking for the general term of that. The general term, and because of this difference, and we are also told that it is arithmetic, it means we know that we are going for Tn is equal to 1 plus Tn is equal to A plus into n minus 1 multiplied by the difference. That is the formula. So we substitute. Tn A is 4, and then we don't know what is n minus 1. The difference is 3. Then we multiply into the bracket. This is 4 plus, we multiply that one there, it gives us 3n. You multiply that one, gives us minus 3. So this and that one are like terms, which means now we are going to have 3n. 4 minus 3 is positive 1. Then this one is nothing else but the general term of this sequence. It is the general term. Questions may follow from there. Find the 8th term. Find the 9th term of this particular. So it will be easier for you. For example, if you are looking for the 10th term of this specific sequence, the 10th term will be nothing else but T10, which will be equal to 3 times 10. Add 1. So it means that will be 30 plus 1, which gives us 31. 31 is term number 10 of this specific sequence. I hope we are together and that, and then we are just going to take something like 5 minutes to do the next one. Right. Can you try that one? Can you try that one quickly in 5 minutes? And then do it's -4, -8, and -12. We still find the general term of the arithmetic sequence that is given. All right. Now I hope folks, all of you have got it now. Let us look at how it goes. The question said, determine the general term of the sequence 4, -8, and -12. So we start again with that and say, the sequence is given there, -4, -8, and -12. Then, as it is, what is A? The first term. The first term is -4. What is the difference? The difference, I hope you realize that it is -4 still. The first term and the difference are the same. So we say our formula is Tn is given by the first term added to n-1 multiplied by the difference. Substitute, the value of A is -4. A is -4, the first term. Add n-1, the difference is -4 still. So the multiplication, I stress this point with the way we multiply, but now what is also important, we must, because we are multiplying here by the difference, put another bracket there. Leaving that bracket can get you confused. You'll end up subtracting there. But now if here the bracket is there, it's safe for you. You'll know that I'll continue with the multiplication. So when we multiply, we multiply this way. Every term must multiply there. Every term must multiply there. So we end up with, when you multiply, this becomes -4, which is this one. And then when you multiply a negative by a positive, this is now -4n. This and that, this you multiply with -4, you end up with a positive because of the two negatives that are multiplying, and then we have 4 there. Lastly, this is -4, that is +4. So they eliminate each other. You are left with -4n. So -4n becomes the general term of that one. I'm sure all of us, that one, we have got it. I can see the way you smile that you have got it correct, this one. There you are. And then now, this is the general term. Like I indicated to you that there are other questions that can arise around the issue of the general term. For an example, it can be said, given the sequence, and then you find the 38th term or the 40th term or the 10th term of that. And then now it becomes a bit easier, because when it is like that, it means you are just going to substitute into that n, substitute your n there, and then you multiply. Now let's take other examples that are relevant and related to what we are doing here. If we look at these numbers, it is not always that you'll get the terms like this. You can get the terms as binomials. And if a term is a binomial, we follow the same thing. There now you'll be able to find the nth term. They will be able to find the number of terms. But before that, let's take an example once more that is going to help us on that. We can say, given the sequence, say the sequence is 99, first term, second 88, the third term 77. And then given this type of a sequence, the question will be, determine the ninth term. Determine T9. Determine the ninth term. The simple as that. You follow the same route. Again, you get the general term of this. You can get the general term. So the general term to that one will be, as it is 99 and 88, you find the difference between the two. And then we'll find that the difference is always, when you subtract this one, you'll get the difference of negative 11. There you also get the difference of negative 11. Because 77 minus 88 is negative 11. 88 minus 99 is negative 11. So in this case, our difference is equal to minus 11. Our first term is given as 99. So what are we looking for? We are looking for term number 9. So for term number 9, it means we'll go back to get the general term of that one. From Tn is given by a plus into n minus 1 multiplied by the difference. We substitute there. A is 99. You add into n minus 1 multiplied by negative 11. Negative 11. Ultimately, we are going to have 99 there. And then we multiply there to get minus 11n. And then you add 11 there. So it means this and that one are also like terms. So we have minus 11n. 99 plus that one, it is going to give us 110. So this is 110. There it is. So this one is the general term for this particular sequence. It's the general term. But now the question is looking for T9. So T9 will be nothing else but will be minus 11 multiplied by 9, which is this one. You add 110 there. I'm sure you are busy with your calculators already playing that. And so this is minus 99. You add 110 to it. It's negative 99. It comes from this one. 11 negative. Then we are looking for T9. And then that is 99 plus 110. So if you get that, the answer becomes 11. Will it be? Right. So you punch that. So it means we are going to have there, what is that? It's 110. You minus 99 to that. Because 99 is negative there. What is the answer? You got it quickly there. So this is 1. And then that one will also give us 1. Which means now that will be positive 11. That is now positive 11 is term number 9. Meaning that as you continue here, term number 9 somewhere there is going to be equal to 11. That's how we get that one. Right, and then let's see now. We continue further and look at how we can get that T9, then the nth term of an arithmetic sequence. The nth term of an arithmetic sequence. Right. Like I indicated, it's not always that we are going to get the term, the sequence with single term, like 3, 5, 7. We can get a sequence that is made up of binomials. For an example, we can have the sequence which is arithmetic, still arithmetic sequence, given as 1 minus p, 2p minus 3, and then p plus 5. We can have that as a sequence. It is arithmetic. Then now, the first question that we would have there, it will be find the value of p. We calculate p. Secondly, it can be asked that you can therefore write down the sequence. Write down the sequence. Thirdly, it say, what is the common difference? What is the common difference? Let's see, how do we go with that together? We have 1 minus p there, given as the first term, 2p minus 3 as the second term, p plus 5 as the third term. Right. So from that one, we will be able to get the value of p as is required. We need to get the sequence, write down the sequence. We need to look at the common difference once more. And then we can quickly rush onto that and say, how to calculate p, what do we know about the arithmetic sequence? We know the arithmetic sequence has a common difference. So the common difference is given by the second term minus the first term. In other words, we are going to have 2p minus 3. We are looking for d. 2p minus 3 minus 1 minus p. That's how it should be. That should be d. And d can also be p plus 5 minus 2p minus 3. We can have that. But these differences are for the same sequence. So it means they must be the same. So it means for us to have that d, we can have now 2p minus 3 minus 1 minus p must be the same as this one, because that is p plus 5 minus 2p minus 3. That's, these two things should need to be the same. And then we can quickly have that one. We know that we are going to have 3p minus 4 being equal to minus p plus 8. Where does that come from? If you multiply this, remember this is going to be negative 1, negative p. This is going to be 2p minus 3 minus 1 plus p. That side it will be p plus 5 minus 2p plus 3. So the like terms that this and that one are giving us 3p. This one and that one are giving us minus 4. P and that one, it is give us minus a p. This and that one are giving us 8. So we group them together. We ultimately have now this side, when this p crosses, we are going to have 4p minus this one, goes that is a 12. That is going to be equal to 0. We are left with nothing there. Ultimately, p is going to be equal to 3. Because from here, we are going to have 4p equals to 12. Dividing by 4 both sides, we can end up with p being equal to 3. And then the last one, to write down the sequence now, because the difference is there. The sequence is there, and the difference is there. We can, the value of p, we take it from there. The first term will be 1 minus 3. The second term will be 2 times 3 minus 3. The third term will be 3 plus 5. Then our sequence will be that one. This will be our sequence. Then this gives us a minus 2. And then this is 6. 6 minus 3 is also 3. It means it's 1 minus p. P is equal to 3. that is it, and then 3 plus, this is p plus 5. 3 plus 5, which is going to be equal to 8. There we are. So it means that the sequence will be that one, 2, 3, and 8. You can check on that. 3 minus is going to give us a 5. This minus that one is also going to give us a 5, meaning the difference is equal to 5 there. So it means this is our common difference. We have also answered the third question. The common difference is equal to 5. So we are going to just take a 5 minutes break, and then we'll come back and do the next session, which is on the different questions that can appear on the general term of an arithmetic sequence. Thank you. See you after 5 minutes. Okay, welcome back, classmates. Welcome back, the matriculants of 2014. I hope we are going to continue now to what with what we are supposed to do after the general term. The next thing that we are going to do now, we are going to look at the sum of terms of a sequence. And then the sum of terms of a sequence is also something that is going to appear on the exam, so that we understand what a sigma is. For an example, we have just made a sequence there. If a sequence stands, sequence say for example like 1, 3, 5, 7. This one we call it a sequence. But if you sum them up now, they become a series, to make an example. Then now, if this is a sequence, 1 plus 3 plus 5 plus 7 plus up to infinity there. This one is called a series. This one is the sequence. If you sum up the terms of a sequence, you get what you call a series. Summing them up is something that one can be done. You know that T1 is equal to 1 in this case, and then T2 is equal to 3, and so forth. But now the sum, when we sum them up, it means we can talk about the sum of the first term. The sum of the first term, what will it be? The sum of the first term will be 1, because we are only adding the first term. So the sum up to 2 terms will be now 1 plus 3, because we are adding the 2 terms. The first term and the second term is sum up to 2 terms. Sum to 3 terms will be 1 plus 3 plus 5. This one will obviously be equal to 1, the sum. That one will be 4. That one will be 9. That is the sum up to 3 terms. The sum to 4 terms will be 1 plus 3 plus 5 plus 7. That will be a sum up to 4 terms, meaning S4 will be 1 plus 3 plus 5 plus 7, which is nothing else but 16. So this one, these values there are the sum. This is the sum to first term. Let's say, for example, we say the sum of the first term, the sum of the first 2 terms of this particular series, the sum of the first 3 terms. You can code you like that. Like we said, it becomes a series. Now we are going to talk about the series if you are adding them together like that. They are them. We talk about the sum. But now the question will be, what will happen if we say we are looking for an example, sum 200 terms? Are we going to sit down and write 1 plus 3 plus 5 plus 7 plus... That will take us a very long time. We'll get old even before we get the solution. So it means that challenges us to get a certain way or get a formula that is going to help us to get that. But it's not very far. Remember, from the previous session that we had, we talked about the general term. It is the general term that takes us to that. So now, for us, in order to get those, it means we must introduce now what we call the sigma. We must introduce the sigma, which is denoted by this letter. That is now the sigma. It talks about the sum of a series, that sigma. So this sigma, it helps us. It is a mathematical symbol anyway that is that we use to represent the sum. Now, it means if we have S of 1 there, S sum of 2 terms, sum of 3 terms, sum of 4, we can represent that by that one. But before we get there, we need to remember, we need to get the general term of a specific series. In this case, we are talking about the series because the sigma works with the series. We add the series. The series comes from the sequence. So the sequence is like that, and then when you add those terms, they give us the series. So we need to have the general term of that series before we can take to that. Let's take the very same one. 1, 5, and 7. 1, 3, 5. But it is the one that we used. Let's try to change and get maybe something different. Let's take the one which was 4. It was 4, 7. It is just nearer here. Let's get that slide a little bit quickly. 4. Or we can have any of those. Let's say, for example, we have 2, 6, 10, 14. This is the sequence. But now to make it a series, it means it's going to be 2 plus 6 plus 10 plus 14. This is going to be a series. So, and then we can add these first 4 terms, but it continues. It continues. The first 4, it will be easier for us. You can take your calculator and add that one, and then you know what is the sum. But if we want the sum of 100 terms of this one, what do we must do? We must get a way, an easier and short way of doing it. But now, in the previous session, we said, in order to get a general term, we must first check, is it arithmetic? Yes, we can check on that. 6 minus 2, it gives us a 4. 10 minus 6, it also gives us a 4. 14 minus 10, it also gives us a 4. Then we conclude that this is arithmetic series. This is an arithmetic series. It is from the arithmetic sequence. And then we get the arithmetic series there. It is arithmetic because we see the common difference. If it is an arithmetic sequence, we remember what must we have. It means we are working with Tn is equal to a plus n minus 1 times d. That's what we have there. So because it is arithmetic. So from here, the general term of this one will be, now that we know that our a is 2, our difference is 4, then we can find the general term. The general term, Tn, is given by a plus into n minus 1 d. I repeatedly say this formula or this general term so that it gets into our mind. It's nice to know the formula by heart. A plus n minus 1 times d. Then we substitute then into that. So a is 2 added to n minus 1. You multiply by the difference, which is now 4. What is that? What is the answer to that? This becomes 2, which is that one, plus we multiply there. Don't forget, we multiply there. This is now 4n. We multiply that one, it gives us minus 4. So our general term Tn for that becomes 2 minus 4 plus 4n. When we group this so that we can subtract them, they are like terms, they are constants. So to continue from there, it means our general term is now 4n, which is that one, and then plus, it's minus 2 minus 4 is 2. This is our general term. Now, in other words, if we use this general term, we can use it to get any term of this series. We can get that. But now we want to get the sum of that. The sum, say for an example, of n terms in this one can be given by the sigma notation, where now this n starts from 1 up to n for the general term 4n minus 2. This is what you can have. So it means the sum up to n terms for this one will be given by that. To say the sigma notation, n starts from 1 up to, let's change the symbol so that we don't get confused. Let's say for an example, this one will be our k, and then k starts from there up to n. We can have that one. And then we change k starts from 1 up to n. And then let's check on that. Is it going to take us back to what we want? Then we look at it this way. When k is 1, it means we're going to have 4 multiplied by 1 minus 2. So this is equal to 4 times 1 is 4. Minus 2, it gives us 2. In other words, we look at our series. The first term, when k is 1, we get 2 there. Let me check for the second one. We know that should be, for the second one, it's when k is equal to 2. When k, it means it's 4 multiplied by 2 minus 2. Let's check on that. 4 times 2 is 8. And then 8 minus 2. We should have a 2, not 1. Because our formula there is 2. 4 times 2 is 8. Minus 2. It is going to give us 6. Does it correspond? Yes, it does. It means now this is the general term on which we can put on a sigma to get that. So it means now it becomes easier. S 100, the sum to 100 terms, will be the sigma notation starting from k starts from 1 up to 100. Then of 4k minus 2. We can have that, right? So it will be, we have just introduced the sigma now that is going to help us to find the sum. But now what is important, we must be able to write any sequence in a sigma notation form. We need to do that. Or you must be able to expand the sigma notation to a sequence, to a series. Now it means if we have the sigma notation, for an example, we want to write a certain sequence in a sigma notation form, we must be able to do that. If we are given the sequence 1, let's say we are given 2, we are given plus 4, plus 6, plus 8, plus 10. We are given that series there. We need to write this series in a sigma notation form. What is the first thing that we need to remember? We need to remember that we must have a general term for this series. The general term, it's easier, it comes from, we must first find the difference. Our difference there, we have realized the difference is equal to 2. And then the value of A is 2 also. This is A, this is our difference. So we can find the general term and say Tn will be given by a plus n minus 1 into d. Substitute, a is 2, add n minus 1, multiply by the difference, which is also 2. We end up with 2 multiplying there, plus 2n, this one is minus 2. So it means 2n, 2 minus 1, 2 minus 2 is 1. So it is going to be plus 1 there. This one is the general term, or the nth term of this particular series. Then now in a sigma notation, it means you can write it as where, let's say, k will start at 1 up to n. In this case, n will be 1, 2, 3, 4, and 5. It means now the sigma notation, k starts from 1 up to 5, because we have 5 terms there. And then for the general term, 2n minus 1 plus 1, 2n plus 1. So we have written this series in a sigma notation form. In other words, we are saying, therefore, 2 plus 4 plus 6 plus 8 plus 10 will be equal to this sigma where k starts from 1 up to 5 of the general term 2n plus 1. This is the same thing. You can also be able to take it from the sigma notation form to the series itself by expanding. We say that we need to expand this. It must be expanded. If you expand it, it means you are taking it back to the series. When you are writing this in a form of a sigma notation, you are taking it to that side. This is what we need to follow to have the general term of an arithmetic series, and then we can write it back there. So the expansion, for example, if we can take that one and say we want to expand the same one, it is easier, or to get the sum of that. But we must first expand it. It means it is given as now this way, k starts from 1 of 2n plus 1. It will be expanded, you say, with k starts from 1 to k. Why to n? To k. We're talking about k and n. Sorry, matriculants. Here it should be k, so that we don't get confused. Or n for both of them. Then it means it will be here 2 into k starts from 1, you add 1. And then plus for the series, the next term, which is 2 times 2, you add 1. And then plus the third one will be 2 into 3, you add 1 to it. And then plus that one will be the fourth one, which is 2 into 4 plus 1. Remember, we have to stop at 5. And then it will be plus the last one, which is now 2 into 5 plus 1. So it means this is 2 times 1, which is 2, plus 1, it gives us a 3. What has happened now? Somehow we have gone wrong now, where we get a 3 instead of a 2. 2 times 1 plus. All right. Now, so sorry for that. We have just realized now we made a mistake now here. We made a mistake here. Remember, this is positive 2, that was negative 2. So they give us a 0. We don't have that. We don't have, let's correct that. We don't have that one. We don't have that one. We must correct that, please. Sorry for that. So it means it's a positive 2 and a negative 2. They eliminate each other. So now our general term is nothing else but now the sigma notation k starts from 1 up to 5 for 2k. There we are. Then we can continue. We've corrected the mistake. You see, these things, they do happen like that, especially when we are in a hurry. Let's totally scratch this out. It's not there anymore. Then we are using our correct general term. It means when we expand, we're saying k will start from 1 up to 5 for the general term 2k. So we have corrected that. So we expand it. It will be 2 times 1 for that one, and then plus 2 times 2, and then we add 2 times 3, we add 2 times 4, then the very last one we add 2 times 5. Thank you, folks. That now we have got it right now. So it means this is going to be the 2 added to a 4 added to a 6 added to a 8, and then you add that to a 10. So we can punch in that this gives us a 6. This is 10, 20, 30. If we add it very well, this gives us 6. This gives us 12. This will give us 20 plus 10. It will be 30. So the sum that will be equal to 30. We must be able to write in either. Either if it is given in a sigma notation form, you expand it to find the sum. If you are given it in a series, you can be able to write it in a sigma notation form. Then let's take this one as another example that we are going to take. Say, I'm sure it is going to take you even something like 10 minutes, not more than 10 minutes to do the 2. I want you to do both of them. So we have this one as 2 for 6. Just a minute. I want you to write this one in a sigma notation form. Geometry. Good. Right. Write the following. Write in sigma notation form. The first one that we write in sigma notation form is -1 plus 3 plus 7 plus blah blah blah. The second one that I want us to do, we'll do together, will be 4 minus 2 and minus 8. Remember, we are adding them. Minus 8. It means this one, let's write it this way. This one is number 2 will be 4 minus 2 minus 8. These are the two series that we have. We want to take the one with the negatives and take the one with the positives. So let's look at those two and see how far we want to write them in a sigma notation form. We are writing them in a sigma notation form. Then let's start. The first one is given as -3 plus, not -3, but -1 plus 3 plus 7 plus, that is the sigma notation. We want to write it in a sigma notation. We said the very first thing that we need to do, we need to realize or get our general term. In this case, A is equal to -1. What is D? D is equal to 3 minus 1 is 4. In other words, here the difference is 4. 7 minus 3, the difference there is 4. It means our difference there is equal to 4. Then we can continue to get the general term. Because we have realized it is arithmetic. Tn is equal to a plus into n minus 1 multiplied by d. Let's find the general term. A is minus 1 added to n minus 1. The difference is 4. We multiply by 4 there. Then our multiplication, we have negative 1 there, plus 4 multiplied by n. 4 multiplied by n, and that's is going to be minus 4. To simplify it further, we're going to have 4n there. These are two negatives. Negative 1, negative 4 is nothing else but negative 5. Here is our general term. So, how many terms do we have that we are looking for? Here we have 3. We have 3, but it's continuing like that. So, if it continues like that, it means we are going to have our sigma notation where k starts from 1 up to infinity, up to n terms of 4n minus 5. Because this one has little dots to show that it is continuing. So that's how we are going to write it in a form of a sigma notation. I think that one is clearer. But the second one that we had, it stops there. It was, we are given 4 minus 2 minus 8. We are given 3 terms. So we wanted to get the sum of the 3 terms there. So once more, we need to look at what is the difference there and what is a. We know that a is equal to 4. The difference will be negative 2, negative 4, which is the same as negative 6. So negative 8 plus, remember these are going to be 2 negatives, plus 2, it is also going to give us a negative 6. So the difference there is negative 6. So we can be able to get our general term. Tn is given by a plus into n minus 1 times d. Substitute, a is 4 plus n minus 1 multiplied by negative 6. This one becomes 4 as the value of a minus 6n when you multiply there, and then plus 6, the positive there. So we end up with negative 6n. These are two with the same signs, positive. So we end up with a 10. This is the general term. So we can write that in a sigma notation and say that 4 minus 2 minus 8 can be equal to, right, then n starts from 1 or k starts from 1. Let's use, we've been using k. Let's use k. Start from 1 to 3 because there are 3 terms. To 3 of minus 6 k plus 10. So k starts from 1 up to 3 since we have 3 terms there. So you can check on it quickly. When k is 1, you have minus 6 times 1, which is minus 6, plus 10, it gives us a 4. When k is 2, minus 6 times 2, it's minus a 12. Minus 12 plus 10, it gives us a 2. So it means we can write that in a sigma notation form. So now, before maybe we end the session today, it will be proper for us to have this one. And then in the next session, I think
we are going to do the sum of that. But now, to finish up this one, we will be able to have some few exercises. So the very first one, if we look at it, we want to get to write these in a form of sigma notation. Do the following in 2 minutes. Write down the following series in a sigma notation form. The first one, it will be 1 minus 1 minus 3. Try that one in 5 minutes. The second one will be 1, 5, 9, 30. The first one has 3 terms. The second one has 4 terms. Let's have those quickly in 5 minutes, and then we'll come back and do them and see if we still have time and get to the next session. All right. Okay, welcome back, folks. From the I hope both of them you are done. Let's look at the first one quickly and check where we're supposed to write this in a sigma notation form. We're given 1, -3. We're given 1, -1, and -3. This is what we're given. So we said the first thing that we need to look at is we need to find our general term. And in our general term, we need the value of A, we need the value for D. So A in this case will be equal to 1. This is the first term. D will be -1, which is that one, minus 1, the first term. Second term minus the first term. This gives us -2. Let's check once more with this one. This is -3. -3 minus -1 will be +1. This is also -2. So we confirm that our difference is -2. Then we can find the general term. The general term is given by this into A plus n minus 1 into D. Substituting, the value for A is 1, added to n minus 1, the difference -2. Then we have the 1 multiplying there, it is now minus 2n. This one is plus 2. So ultimately we have -2n, which is that one, and then is added to 3. This is Tn. Therefore, it means 1 minus 1 minus 3 will be equal to the sigma notation, say k starts from 1 up to 3 of 2k plus 3. Then we have written it in a sigma notation. I hope we all got that right. Then the second one, quickly, we were given 1 plus 5 plus 9 plus 13. Then the difference is 4.
The difference between that one is 4. The difference there is 4. The difference is also 4 there. The value for A is 1. The value for D is 4. Tn A plus into n minus 1 D. Substitute 1 there. The value for A. Add n minus 1. Substitute D. D is 4. So that is now 1. When you multiply there, you get 4n. When you multiply there, you get minus 4. We can finish it up there. Therefore, we are going to have 4n. Minus 4 plus 1 is nothing else but minus 3. This is Tn. So it means that series will be which is 1 plus 5. Therefore 1 plus 5 plus 9 plus 13 will be given by the sigma notation, where say k starts from 1 up to 4, since we have 4 terms, and then we are going to have 4n minus 3 as our general term. So we can check on those that they will take us back. If k is 1, if k is 1, 4 by 1 is 4 minus 3, it gives us a 1. When k is 2, 4 by 2 is 8, take out 3, you'll get a 5, and so on and so on. Right. So that's how we got those to write the sigma, to write the series in a form of a sigma notation. So the other way around, you must be able to expand from there up to that one. Right. Since now we are already a little bit ran out of time, it would be good to visit all the question papers that were written in the previous years, and then do the exercises on arithmetic, sequence, and series. Next time when we meet, we're just going to finish up and look at the sum up to n terms of an arithmetic sequence, of an arithmetic series, whereby the first term is a, the second term is a plus d, the third term is a plus 2d, and then we are going to take it from that one. Thank you for coming. I know it is not easy. The weather is not very well, especially in Bloemfontein. We can see, but now all of you just made it to the lessons, and then we thank you very much for that. See you next time. Bye-bye.